two of those questions just so that some of you can feel a little more confident about the graphing, and I think specifically about choosing the X values to use. So it's kind of like when we were doing radical graphs, those square root graphs, you had to pick specific X values based off of the numbers in your radical. So in this case, we're going to try and use specific X values based off of the numbers in our fraction. So we'll kind of go through that and review why you would pick certain numbers. So I'm going to start with number 19. And 19 has a -4 on top. And then underneath that, we have the X plus 4. And then to the side, there's that plus 3. So yesterday, we talked about all these graphs having two asymptotes. So one of them is going to be a vertical asymptote, and you will see that I will start just saying VA for vertical asymptote. That one's in X equals because that makes a vertical line. And then we have a horizontal asymptote, and that one is in Y equals. So the va and the ha. And again, this is going to be consistent with all of these rational functions. So that's like a property or a characteristic of a rational function. So Ava M, what would the vertical asymptote be in this equation for number 19?
Would it be X equals -4?
Yeah, so it is going to be X equals -4. And then Ava, how about the horizontal asymptote?
Y equals 3.
Perfect, Y equals 3. So I would strongly suggest before you do anything else, sketch those two lines in. So before you pick X values, sketch in your vertical asymptote at -4. And then the horizontal asymptote at +3. It's a little off. So when you choose your X values, you need to look at that asymptote at -4, and you need to pick 3 points to the left and then 3 points to the right. Some of you are picking all the numbers on one side or picking one number on one side and all the numbers on the other, but you need a few numbers on each side to get those curved branches. So if my asymptote is at -4, I could pick the next number, -5, because -5 plus 4 makes -1, and that's an easy number to divide with. The next number, maybe I want to pick a -6, because if I plug a -6 into the denominator, then I have a 2. So I'm like looking at that denominator as well when I'm choosing numbers. And then I still want to pick one more number. So thinking that my asymptote is at -4, I just chose -5 and -6. Maybe you want to pick -8 because -8 plus 4 makes a -4. But I'm trying to look at the denominator and choose my numbers so that it works nicely with the number on top, that numerator of -4. So now I have three numbers that are to the left of -4. So then going to the right, I might as well pick the one right next to it, a -3. And then choose a -2 because again, -2 plus 4 makes 2. So that one's a good one to pick. And then maybe we'll pick 0. Because if I plug a 0 in, 0 plus 4 gives me 4. So I'm trying to, again, choose numbers. Not only do they have to be to the left and the right of the asymptote, but I want them to work nicely. So now I have the x's. When you plug them in, they should work out pretty nicely with your fraction. So you have a -4, you're plugging in a -8 plus 4, and then you're adding 3 to it. Brooke, if I used a -8, did you use a -8, Brooke?
Yeah.
What'd you get when you plugged in -8?
4.
Did you use -6, Brooke?
Yeah.
What'd you get there?
5.
And then if you have a -5, you get
Hold on. 7? 7?
yeah, you're right. You're good. Yep.
Okay.
Yep.
-1.
Uh-huh.
5. Would be -5? No. Wait. I'm sorry. I'm trying to do this really quickly.
No, you're good. You're good. You were doing fine. So plug in a 2.
So
So that would give you -2 plus 2, which is
wouldn't it 1? It's not +2, it's +3, but so
oh,
it'd be
no, no. Yep. You're right. 1.
and
And then the
then
last one.
oh Lord. Okay, 4. 2.
There, that's 2. Yep. There you go.
Oh boy.
Nice. Good, quick mental math. Nice job. All right. So then we have our numbers. Now we're going to just plot some points. So at -8, you're up at 4. And then at -6, we're up at 5. And then at -5, we go up to 7. And now I can see that curved branch. So 3 points. Make sure you curve your branch then along the asymptote. And then the other 3 values. So at -3, we have a -1, at -2, and then at 0. And those 2 branches should be symmetrical. So they should also be a reflection. If I flip over diagonally, my branches should look the same. They're going to be in opposite quadrants. Questions? All right, let's look at 21. Go over another one. So Valerio, what would the horizontal or the vertical and the horizontal asymptote be for number 21?
4 and -1.
Yeah, so this time it's a +4. That's the H value. That minus sign is part of the equation. And then he said -1. So before I do anything, I'm going to graph in that asymptote at 4 and at -1 this time. So when you look at the X values that you're choosing, this time you're now looking at that vertical asymptote that is at +4. So I would start at that asymptote and then just work my way to the left. So Valerio, can you tell me some X values that you used?
I used -2, 1, 3, 5, 7, and 10.
Okay. So the numbers he chose here, if you plug them into the denominator, it gives us pretty nice values to divide with. So that works nicely with -3. So if you plug a -2 in the denominator, you have -6. So Valeria, what'd you get for y when you plugged in -2?
-1/2.
Yeah, and it's okay to have a fraction. It might happen, but it should be a decent fraction like a -1/2 here. But yeah, that could definitely happen. Valeria, when you plugged in a 1, you got
0,
a 3,
2,
a 5,
-4,
and then 7 and 10.
-2, and -1/2.
Yeah. You said -1.5. So have your X values, found the Y, graphing them, plotting some points here, and then making that curved branch connecting those 3 points. So you always have a point that has a pretty steep value, and then you should have a point that would be close to those asymptotes as well, because the horizontal asymptote is where it goes horizontal. So I have those points that are smaller, closer to the asymptote, but then I have that one that's steep that gets close to the Y, or the vertical asymptote, to show us how it's going vertically. So that Y value being a little steeper. Questions? So you will have to think a little bit when you're picking your X values, but you really need to rely on that vertical asymptote. Please make sure you're looking at that asymptote. You need to have 3 points to the left and 3 points to the right. And if it helps, maybe even in your T-chart, like maybe separate your T-chart and say, all right, my vertical asymptote is at X equals 4. So I want to have 3 numbers below it, or 3 numbers to the left of it, and then 3 numbers to the right. But it might help for you to kind of separate that T-chart as well if you're having a hard time picking your X values. So we are going to do 2 more graphs, and hopefully after we do those 2 graphs, you'll feel a little more comfortable. In your notes, we are going to go to page 9. And we are at the top of page 9. So at the top of page 9, I said we were graphing a slightly different form of a rational function, but we were going to be finding the same thing. And if you look at this form, this is one of the most common forms of a rational function, where you have a linear equation on the top and a linear equation on the bottom. So just looking here at the example A, y equals 4x minus 2 divided by x minus 1. So a linear equation at the top and a linear equation on the bottom. This makes a rational function. So a rational function is pretty much one equation divided by another equation. And they don't always both have to be linear, but this is a very common form. So we are going to still find asymptotes, still a vertical and a horizontal. The vertical asymptote is going to be found when you take the denominator and set it equal to 0. So I'm going to make a little note up here. The vertical asymptote is when we take the denominator and set it equal to 0. Because that's where the X value is undefined, and that's what makes a vertical asymptote. The horizontal asymptote is found by the coefficients in front of the x's. So if I look in the numerator, there's an ax, and in the denominator, there's a cx. The horizontal asymptote is found from those coefficients, and that would be the number on the top, the coefficient on the top x, divided by the coefficient of the bottom x. And you will see when we move on tomorrow and continue graphing these rational functions, that is going to be one of the properties of horizontal asymptotes that we talk about. And we will find a vertical asymptote every single time by setting the denominator equal to 0. Once it's out of that basic form, that H and K form. So once it's out of H and K form, we'll be setting the denominator equal to 0. So in this first example, it says, again, draw the asymptotes. Solve x minus 1 equals 0 for the x to find the vertical asymptote. So Jaden, what would our vertical asymptote be if I solved that little equation x minus 1 equals 0?
1.
Yeah. And then Jaden, it says the horizontal asymptote is the line y equals a over c. So what is the a value and what is the c value in our rational equation?
So the a value, would it be 1 over 1? So would it still be 1?
So if I look at this equation, what number is in front of x?
Oh, that equation, sorry.
Yeah, no, you're good. My fault.
So it would be 4 over 1.
Yeah, so 4 over 1, and that just becomes 4.
Oh,
So
4.
you're good. Nope, you're good. So we're looking at that original equation, and we're going to take the number in front of x that's on the top, the numerator, and then the number in front of x in the denominator. And that gets us our horizontal asymptote. So top number divided by bottom number. So we're going to graph them again right away. When you find them, graph them. So our vertical asymptote is at x equals 1. So we're graphing a vertical line at x equals 1. The horizontal asymptote is all the way up at 4. And then I have some points up here that I chose. I'm just going to write them again. So it says plot points to the left, such as -1 and 0, and points to the right, such as 2 and 3. So in between here has to be that asymptote at 1. So it might help you to draw in that asymptote to kind of divide up your graph. So when you're plugging these in, I really need you to start thinking more mental than relying on that calculator. And this is going to benefit you moving into trig and pre-calc next year, especially those of you taking honors trig and pre-calc. The less you rely on your calculator for the last quarter of the year, the more prepared you will be for honors trig and pre-calc. So looking at 4x minus 2 over x minus 1. So you're plugging in a -1. And then you're plugging in a -1. If you need to do a little side work, okay. Do it mentally, awesome. But that gives me a -6 divided by a -2, which is a +3. The more you use your mental math, the quicker it will become for you, instead of always relying on that calculator. So on the top, I have a -2. The bottom is a -1. That gives me a +2. So now I have 6 over 1, which is 6. And then finally, when I plug a 3 in, I have 10 over 2, which gives me a 5. So yes, you could pick more points. My graph is only so big, but we could have chosen a couple other points as well. But let's see if these 2 points work for us. So we have a value at -1 and up at 3, and then at 0, we're at 2. So I know there's only 2 points there, but knowing what the graph should look like from those 2 points, we should be able to make a curve, use the asymptotes to help make a graph. So use the asymptotes to help get that curve of the graph. They're actually boundary lines. They're grid lines for us to follow. So again, I know I only have 2 points, but we're not connecting those 2 points with a line. We're connecting those 2 points with a curve, a branch. And my asymptotes are also help creating that curve. So then the last question zone here, what is the domain and the range? Madison, do you know what the domain and the range would be for this graph? Start with the domain.
Would the domain just be 0, infinity?
So looking at, do the left piece. So look at that left branch and just describe the domain of the left. So my black branch on the left side, what would that domain look like? So it starts at -infinity, and where does it go to? What's the x value that it's stopping at? Or what's the asymptote? Let me ask that. What's the asymptote here? So it's going to stop at +1. So it's going to go from -infinity. So it's right now at -infinity, and then it curves down at the x value of +1. So even though it's curving down, that x value where it starts curving is at 1. And then if I get the other one, the other branch, so it's starting at +1 and it curves forever to positive infinity. So from 1 to infinity. So that would be our domain. Ava R., do you think you could do the range?
Would it be negative infinity to 4 and then 4 to infinity?
Yeah. So notice this +1 is our vertical asymptote. The 4 is the horizontal asymptote. Those actually help create the domain and the range. So the vertical asymptote is in the domain, the horizontal asymptote is in the range. Any questions on that graph? So we're going to look at one more that is of this form. So start with the vertical asymptote and the horizontal asymptote. And then we'll make a T chart in a minute. So this one's a little different. It's like the one we just did. Doesn't have an H and a K. So Faith, to find the vertical asymptote, looking at what we did for the previous problem, how would you find the vertical asymptote, Faith?
Isn't the denominator 0?
Yeah, so that denominator says negative x minus 2 equals 0. So if you solve for x, Faith, what do you get?
2.
You're so close. It's a negative x.
Oh yeah, -2.
Yeah, so it's going to be a -2. So there's my vertical asymptote at -2. And then Faith, to get the horizontal asymptote, we're going to get those coefficients. So what would the horizontal asymptote be?
Y equals
So the number in front of x from the top divided by the number in front of x on the bottom.
4 divided by -1.
I think, so what number is on top?
-2.
Yeah, so
Oh.
-2 divided by
I was
-1 is.
looking at the wrong
That's what I
thing.
figured. I figured you were looking at the other one. So -2 divided by
Yeah.
-1 is what, Faith?
2.
There we go. So much more difficult being online when you're now used to being in class, because I can point to things on the board and I can't quite point as easily with the iPad, besides kind of making some arrows and highlighting stuff. All right, so again, got the asymptote vertical, graph it at -2. Watch this graph, it's counting by 2s. There we go. And then horizontal is also up at 2. All right, this one's a little trickier, picking those x values. And I need you to at least pick 2 on each side. So if you like having 3 to get more of a curve, that's fine. But we need to at least pick 2 of them. And the x value that we have, I'll just dash this in, kind of in the middle. So I have an x value at -2. So I need to pick 2 numbers to the left and 2 numbers to the right. And sometimes it helps to spread them out a little bit, especially if you're only picking 2 numbers. So maybe pick a number that's a couple away from the previous one. But -3 is right after -2. And then pick maybe one that's like a few more points away. So maybe like at a -7. And then I get some distance between those two. you can always pick the one right after the asymptote. So if I have an asymptote at -2, I'm going to choose -3 and -1. And the reason I want to do that is because that gets me then the steepness of that graph traveling along the asymptote. And then I chose -7 and -3. So I'm going to pick again, there's 4 x values in between there. So -1, and then I'll pick +3 so that there's 4 x values in between, just to keep it symmetrical. So see if you can plug those numbers in. I'll give you a minute here. And find your Y values from your T-chart. When you're dealing with fractions, it really helps for you to just calculate a number on the top, calculate a number on the bottom. Again, try and stretch that brain, use those mental abilities. For the last 3 months in honors trig and pre-calc, the only numbers we have been working with have been fractions. And not only are they fractions, they have radicals inside the fractions. They have not used a calculator. So fractions, radicals, no calculator, all mental math. All right, somebody have those 4 values. Gabby Soul, how you doing with your T-chart?
I think I have them.
Okay, what do you have?
So for -7, it would be 3.
Yep,
-3, it would be 7.
nice.
-1 would be -3.
And
And would 3 be 1?
awesome, nice job, Gabby. Very nice. All right, so plotting them, those worked out pretty nicely. Again, we only have 2 points, but try and think that it has to be a curved branch. And again, on the other side, plotting those 2 points, but making it a curved branch. So when you're picking those x values, try and choose x values right next to the asymptote. So my asymptote was on -3 or -2. I chose 1 at -3 to the left, -1 to the right. And then I chose one that was a little further away. There are 4 x's between them. And you can make it symmetrical. So if you pick 4 x's to the left, 4 spaces to the left, choose 4 spaces to the right so that your graph looks very symmetrical. Questions? The more you graph, the more comfortable you will become. And as I said, we're graphing all week. So we're graphing tomorrow, we're graphing Friday, we're graphing Monday even. So we will be spending a lot of time just on graphing these because we're going to kind of tweak this equation each day a little bit. And with a little extra that we tweak it, it'll kind of just add a little bit extra to the graph. So if you will go to Google Classroom, you have a worksheet today. And the first part of the worksheet is actually just finding the asymptotes, and it's not graphing. So it's just getting you to kind of recognize how to find an asymptote from your function. So I'll let you pull this graph up or this worksheet up. I also included bigger graphs because I feel like the 6 graphs on here are small and they're all counting by 2. So in the actual assignment, I included the graphs that I always include, the graph paper. So if you'd rather use the larger graph paper instead of the tiny little graphs that are counting by 2, you can do that as well. And then there's an answer key on here too. So you got everything on that assignment to kind of help you. So looking at the first 6 problems, find the vertical and the horizontal asymptote of the function. Notice number 1 is different than the other 5. So number 1 is the form x minus h plus k. Your vertical asymptote is at x equals h. The horizontal asymptote is at x equals, or y, not x, equals k. That's the one that's different. And then if you're looking at those graphs, look at number 12. Maybe circle that one because the graph of 12 is a little different as well than the graph of than all the other graphs. So these other graphs on here will be like the one we did today. So if we look at number 2, to find the vertical asymptote, we take the denominator and set it equal to 0. And again, that's going to be the same setup that we do the rest of the week when we're finding vertical asymptotes. We'll be using the denominator and setting it equal to 0. So Annabelle, if we take that denominator and solve for x, what do you get for the vertical asymptote?
4/3.
Yeah. And then Annabelle, how do you find a horizontal asymptote when it's in this fraction form?
You divide the coefficients on the top and bottom.
Yeah, so that would be
2/3.
2/3. So that's all you're doing for 3, 4, 5, 6. So number 1 is the form that we talked about yesterday. The rest of it is the form we talked about today. And then looking at those graphs, 7, 8, 9, 10, and 11 are the form we used today. Number 12 is the one that's different. So you have about 8 minutes remaining. You can work on this worksheet. If you have any questions, feel free to stay on.